2.6 similar figures. So similar figures are the dilations. So what we're going to use is, well, we're going to start with congruent figures. Well, congruent figures, and remember this symbol means congruent, and they have the same angles and same sides. That's what congruent means. Now, similar, it has the same angles, but the sizes may be different, but it's specific in that it must have different by a scale factor, meaning that they are proportional. So we use the word proportional in that same kind of meaning. So this symbol right here means similar. Kind of like that congruent symbol. It's just the top part that it means. All right, so for an example, here we have to, in example 1, determine whether the figures are similar. So I can see that they're not congruent, but I don't know if they're similar or not. So there's a couple ways. Remember, similar is either angles or sides. Well, wait a minute. I can use the scale factor. So we can look for a scale factor that is consistent or constant. So I'm going to look at the points A, B, and C since it's on a coordinate pair, and I'm going to write down those coordinate pairs for each. So A is 0, the 0 comes first, 3, and then B is 3, 3. C is 3, then 0, so the 0 comes after. Now I'm going to put it in that same order. So the corresponding A would, if it corresponds with J, B corresponds with K, and C corresponds with L. And then I'll get those coordinate pairs too also. So 0, 6 is J, K is 6, 6, and L is 6, 0. So now in looking at this, I can see that 0 and 0, 3, 6, I'm matching up the X's, 3 to 6, 3 to 6, 3 to 6. Those are all times 2. And if I did that for each one of these, that means my scale factor is 2. So triangle ABC is similar to triangle JKL. And remember, it has to be in that same order with those corresponding points or corresponding angles and corresponding sides. So another way we could look at that is the side lengths also. So AB, so side AB, and has a side of 3, and A corresponds with J, B corresponds with K, so that side length, JK, is 6 up here. So we can kind of see that that one is a times 2 also. But we also have to make sure not just one side, but all sides. So we can see that BC is 3 and KL is 6. So that's got that scale factor of times 2. And this is where I like to put my times. I like to draw my arrow in there. It really helps me think through the problem and just kind of what's happening mathematically, drawing that arrow from one to the other is that times 2. And I find putting my scale factor in a box really helps me. So if we take a look at example 2, example 2 says figure A is similar to figure B, meaning A to B. All right, so describe a similarity transformation between the figures. All right, so we're going to start with our red one. Our A is the first one. So we're going to look at A. Transformations. So let's see. They're not the same size. So I probably need to do a similar dilation. So I'll try that first. So let's look at red, and I'm going to label them just to help me organize my thinking. So if we start with, let's start with here, A, B, C, and D. So A is 4, -2. So I'll start with A, B. A was 4, -2. C, and D. I'll get my structure here first. Comma, comma, comma. I like doing that first. So B is, let's see, 7 is here. So 8 would be B. So we have to watch out for that because sometimes they don't put all the numbers, but we know it's an 8. 8, and it goes down 2. So 8, -2. Then C would be 6. Ooh, what number is that? 5, -4, -5, -6. So 6, -6. And D is 4, -4. Now, if I want to kind of think how I do my my dilations, I'm going to kind of go A prime, B prime, C prime, D prime to kind of show that that's my second, or my image to get to B. So let's see, if I need to kind of get it smaller, I'm going to multiply by 1/2. Try that first. Otherwise, I'll do 1/3. But I'm going to try that times 1/2 because they all seem to be even, or most of them are even. Oh, yeah, they all are even. So that might be my first. If that doesn't work, I might try a 1/4 or something like that. But let's try a 1/2 since it's easy. 4, 1/2 of 4 is 2. 1/2 of -2 is -1. 1/2 of 8 is 4. 1/2 of -2 is -1. 1/2 of 6 is 3, and -3, 2, and -2. So I just took 1/2 of those. Now I'm going to plot those. So 2, -1 is A prime. 4, -1 is B prime. 3, -3 is C prime. And 2, -2 is B prime. So let me shade that in and see if that is, it is congruent now. So I can see that that's congruent. So now I'm going to think about, how can I get that over there? So I'm going to reflect. Oh, I want a blue. I'm going to use the blue one. Reflect across. Now, remember, this reflection it's kind of the reflect across this line right there, and that is the x-axis. So I'm going to reflect across x-axis. That is my directions, and that would be my x-axis. I can see it here. So A kind of would be, the next one would be double prime, B double prime, C double prime, D double prime. I know it's not like shown here, but what we're going to do is reflect that and write those coordinate pairs, because they might ask for that in a problem. So A reflects up to here, so that would be A double prime, so that would be 2, 1. B is this one, B prime was this one, so reflect, so that would be B double prime, so that would be 4, 1. C was reflected up to here because it was 3 down, so 3 up. So 3, 3 would be the coordinate pair. And D was 2 down, so it has to be 2 up. So that would be D prime. So 2, 2 would be that coordinate pair. So the directions describe a similarity transformation. So there is 2 steps. So the first step was with this one. So I'll do that in black. So number 1 step was to dilate with a scale factor of 1/2. And that was that times 1/2 for each of those. Now the second one, the second step I had to do, number 2, was to reflect. And I do need the across the x-axis. And that helps me like really get the details in there. Now with the scale factor, you could have said, instead of scale factor of 1/2, you could have used k equals 1/2 and used more of the symbol part of that. All right, example 3. When we use this, we need to determine if this is the length of a unknown side. So that's how we use it. And it's called an indirect measure is what it's called, but in mathematics. But really we just have to find this one. And sometimes I like to do is call it X, just because it helps me kind of organize my thinking. Right here, this means it's similar, so that those triangles are similar, meaning the angles are all the same, so the shape is the same, but the side lengths are different. So I'm going to look at these two, because these two are corresponding sides. So we know that they are similar because they have the same angles, but different sides. But with those different sides, they have a scale factor. So that's what we're going to look for. So here we have 3 to 9. Oh, well, that's a times 3, I know for sure. And if I look at this 4, just to kind of, the 4 corresponds with the 12 side, because they're both going up and they're kind of like the longer leg side. So 4 times 3 is 12. So that means, wait a minute, I can't start with a number. So this is the cool part about scale factor, is if you go one direction, that would be 3 over 1. And if we go the other direction, the arrow going the other way. Now, I know some people don't put their arrows in because they're like, it's just a line. I know which direction it's going. Well, if you just put a line, you don't know which way you're going. So if you're going one direction, it's times 3. And if you go the other direction, the scale factor is that reciprocal. So what's kind of neat is once you have a multiplier, a scale factor, you can just take that, make it a fraction if it's not, and use the reciprocal, so flip that fraction. And what that does is it helps us with the calculation. Now, I know these numbers work nicely, but we're going to get to one here that's not so nice numbers. So this process really helps us organize our thinking. So I want to start with the 15 and go to the x, which would be a times 1/3. So that would be 15. The math would be 15 times 1/3, which would be over 1, which would be 15 over 3, which is 5. And you've probably already guessed that already, because what number times 3 is 15? And so you've worked with that number a lot, and it does work that way. But what happens is this example number 4. The numbers don't work as nice. And so here we have down here, we know that this arrow, if we go from here to here, we want to find the scale factor. So let's put that in there, scale factor. So what is that scale factor? So we know that they are similar because of that symbol, or it might state it in a sentence. So that means that the angles are all the same, or corresponding angles are the same, but our multiplier, our scale factor, 18 times what is 12? Well, I definitely know it's a fraction. Okay, and it's not like the last one where we could figure it out because it's part of our multiplication table. So what I like to do, and this works for every scale factor, is I know it's a fraction, so I'm going to put my times fraction here. And what I do is I circle my corresponding angles. So circling my corresponding angles gives me those numbers. I don't have to go searching for that fraction. I have a fraction, 18 over 12, or 12 over 18. I have my numbers. So now I use my number sense to go, okay, if I'm starting at a larger number and I'm going to a smaller number, that means I am going to need to have the larger number on top. No, the smaller number goes on top and the larger number goes on the bottom. Now, if I switch directions and I go the other direction, so I'm switching my arrow to the other direction, I'm starting with the small number and going to the bigger number. So that means my bigger number is on top and my smaller number is on the bottom. And do you see how that's just the reciprocal of each? But I want the red one because my arrow is going from the bigger one to the smaller one. So now I can simplify that. So what goes into 12 and 18 is 3. 3 goes into 12 4 times, and 3 goes into 18 6 times. Oh, I can do another one. So 2 goes into both. So 2 goes into 4 twice. 2 goes into 6 3 times. So my scale factor of these similar figures is 2/3. And that's going from the larger to the smaller. Now, the scale factor from the other way, scale factor from the smaller to the larger, is that reciprocal of that. And I could see that that simplifies to 3 over 2 as my scale factor. And I always put that times number in front of it because that helps me go, oh, it's scale factor. It's a multiplier. It's always that multiplier for scale factor. So our answer to this, find the scale factor, because the arrow is given to us from the larger to the smaller, has to be the 2/3 multiplied by a smaller number than 1 but greater than 0. Now, how do we apply that to an example? And it's usually a tree problem or a flagpole problem. And that's how I kind of think of these two, as the scale factor. Now, this one's more complicated. Why was this one up here easier? Well, easier is not that so much the number, the fraction number, but easier to think about is because we have two figures that are separated. Here, they're kind of together. So a strategy, and this is a really good strategy, I use this one myself, is to draw two triangles. We have a big triangle and we have a small triangle. So most people see the small triangle, 5 feet and 8 feet. So let's label them. Now, the big triangle is a little bit more complicated. We have right here is a person standing. But if I cut that off and only use that, that's no longer a triangle. And it's the small triangle. So this bottom length is 24 feet. That's how long that is from the tree here, from the tree right here, all the way past the person to this point. Now, what that means is that a shadow, so if there's the sun up here, there might be a sun or a lamp or something, and it's making a shadow of the person and the tree. So that person's shadow is 8 feet long, but the tree shadow is this full length of 24. Now, here's what I want you to do. I want you to write down another sentence right underneath here, because this sentence also is given to us without the 24 feet. This one it is, but let's pretend that they didn't give us this 24 feet. They might give us a sentence, and it's usually this sentence that says, the person, and I want you to write this on your paper, is standing 16 feet away from the tree. Now, what that means in our picture is that this distance right here is 16 feet. And a lot of times they won't put it in, they'll leave it in the sentence, but they won't put it in here. So that's our job to put it in, and that goes right to here is 16. Now, what a common mistake is to put 16 right here because that's what's given is the 16 feet. But at this level of mathematics, what they are saying is, can you come up with the 24 right here? Where does 24 come from? Well, it comes from 16 plus 8. So 16 plus 8 is our 24 feet. So that's why this is 24 feet when we are given this 16 feet away. The person is away from the tree. That's that distance from the person to the tree. Only this section right here is that 16 feet. So they're like giving us a little bit of information, but not all of it together. So we need that 24 feet. So how do we find the scale factor? Well, we look at and find out our height of our tree. And I kind of put an X there. That's how I like to think about it. So I'm going to circle my corresponding sides. The 8 and the 24 go together. Draw my arrow because that's the direction I want to go from 5 to X is to use that scale factor going up. So that would be a times 2 is my scale factor. No, not times 2, times 3. 3 times 8 is 24. Why do I have 2 in my head? You know what I remembered? It's right here. 8 to the 16 would be the wrong scale factor of times 2. And that's why we want to make sure that we get those together, the 8 and 16. So, because the wrong answer would be 10, it has to be times 3 because 8 times 3 is 24. So that means up here, 5 times 3 is 15. So the tree is 15 feet tall. And a common problem is to write the tree is 10 feet. So we want to make sure that we get that 24 total if we're given that 16 and the 8. See how they're sort of separated in the problem? We have to put them together to get that 24. All right, so similar figures are same angles and differ by a scale factor. Corresponding sides are proportional. And corresponding angles are the same, or we can use the word congruent. That would be probably a better mathematical word to use, congruent, but they are the same, meaning that the sides are different, but proportionally different. That's why I didn't put different up here, because you could have different proportional sides like that aren't proportional, which would make it look different, but then that would change your angles. And that is using scale factor in finding similar figures.